Hi, this is Ms. Park. In this video, we will be solving quadratic word problems that require solving a quadratic equation. This is not to be confused with solving maximum and minimum problems. This is solving. So let me show you the difference. If I have a quadratic relation that goes like this, okay, solving the equation means setting ax squared plus bx plus c equals 0. Okay, and the 0 means we're finding the x-intercept, right? When we make y equal to 0, we are finding the x-intercept. So that's with solving. Max-min problems look for the vertex. Okay, this is the max-min. And so when we're doing problems that require solving, we are going to use our methods of solving the equation, like factoring or quadratic formula. Okay, so we'll use factoring or quadratic formula. Whereas if we're trying to find the max-min, we're going to do completing the square. Okay, so two different kinds of solving problems with quadratics. There's max-min, and then there's the ones that are for solving equations. Okay, so let me go to an example. I'm going to do two examples with you for solving equations. So example number 1 goes like this. The sum of the squares of two consecutive numbers is 113. Determine the numbers. Okay, so let's talk for a second about this language here. The sum of the squares. So we know the word sum is what you get when you add. Squares is when you take a number and you raise to the exponent 2. Okay, and the word consecutive means one after the other. So for example, consecutive numbers would be 4 and 5. Okay, 4, 5, or 19 and 20. Okay, two numbers that come one after the other. All right, so it's saying that the sum is 113. Determine the numbers. So to solve this question, first of all, we need a variable. So even if I use x, it's fine. I can use x, but I need a let statement, okay, which introduces the introduces the variable. Okay, statement. Okay. Okay, so it goes like this. Let pick a variable to represent numbers. I'm going to pick n, not x. Let n represent the first number. And now my second number, I could use a different variable, but when we're doing quadratics, there's always one variable, right? ax squared plus bx plus c, there's only one x. So if n is the first one, then the other one, then the one comes right after, will be n plus 1. So n plus 1 represents the second number. Okay, and now I need an equation. Okay, so I got my let statement, I've defined it, now I need an equation. My equation is going to be, well, the sum of the squares. So the square of the first number is n squared, okay, and then the square of the second number is n plus 1 squared. When you add them up, you get 113. And so now we have to solve it. Okay, so we got my let statement, got my variable, and now I got my equation. So now I'm going to solve it. N squared plus, now this n plus 1 squared is n plus 1 times n plus 1, and that equals 113. Expand, so I'm going to get n squared plus n plus n plus 1 is 113, and 2n squared plus 2n plus 1. Now, quadratic equation has everything on the left side and equal to 0. Right, so ax squared plus bx plus c equals 0. This is what I want. Okay, I want it to look like this. And now I have 2n squared plus 2n minus 112 equals 0. Notice that there's a common factor here. There's a common factor of 2. So I can actually, I can factor out the 2 and put it out front to make my number smaller. And I get plus n minus 56. Okay, equals 0. And not only can I factor out the 2, I can actually divide both sides by 2. So if I divide both sides by 2, I get n squared plus n minus 56 equals still 0. Okay, what I did here is I divide both sides by 2. Okay, and 0 divided by 2 is still 0, so it's like that. So it just stays like that. Now it's a simple trinomial. I can go right to the brackets if I want to solve by factoring. And then two numbers that multiply to negative 56 and add to 1. So I got 1 and 56. I got 2 and 28. I think 4 goes in there. 4 times 14. And then 5 doesn't go, 6 doesn't go, 7 goes. 7 times 8. Oh, there's my pair that's going to give me the plus 1. So I had to make that negative. And so it's a simple trinomial, so the two numbers go right into the bracket. Okay, and then solving by factoring tells me that n minus 7 equals 0 or n plus 8 equals 0. And so n equals 7 or n equals negative 8. Okay, now you might think that these are the two numbers, right? Remember they said two consecutive numbers. And you might say, oh, look, I got my two answers. So the two numbers are 7 and negative 8. Well, that's actually not right because 7 and negative 8 are not consecutive. They're not one after the other. So we refer back to the let statement and it says n is the first number. So what we did when we solved our equation, we actually only got the first number. We didn't get the first and the second. So we got the first number. So therefore, the first number is 7 and the second number is n plus 1, which is 8. Or the first number is negative 8 and the second number is n plus 1, which is negative 8 plus 1, which is negative 7. So our final answer, so our concluding statement, is that we have to look at there's two sets of answers here. Therefore, the numbers are 7, 8, or negative 8, negative 7. Okay, two sets of answers. So when we do a word problem with solving equations, we're going to have three parts. We have a let statement that introduces the variable. We have an equation, which we're then going to solve. And then we have the concluding statement in which we have to interpret the solution that we got so that it makes sense for the question. Okay, so that's one type of problem. I'm going to do another type of problem that's called a border problem. And this is a very common problem. And it looks like this. A rectangular lawn measuring 8 meters by 4 meters is surrounded by a flower bed of uniform width. So you have a rectangular lawn with a flower bed all around of uniform width. So again, let's talk about the words. Okay, so you have a rectangular lawn, so it's a piece of grass like this. And what they have is they have this flower bed, so they have this thing with flowers all the way around. So it's called a border problem. So here's the flowers, nice pretty flowers all around. It's called a border problem because you have a rectangle and it's got some kind of border all around. Okay, now they do tell us that the lawn, the inside part, measures 8 meters by 4 meters. So this is 8 meters and this is 4 meters. Okay, and then it says that the flower bed has a uniform width. Uniform width means that it's the same width all around. Okay, which means that this width from here to here is the same as this width here, and it's the same as this width here, and it's the same as this width here. Okay, it's all around. And then it's saying, what is the width of the flower bed if the combined area of the lawn and the flower bed is 165 square meters. Okay, so this is what they're telling us of is the combined area of the lawn and the flower bed is 165 meters. And they're asking, squared. And they're asking how wide is the flower bed. Okay. When you read these questions, look for the question part of the question. Here's the question part. How wide? Okay, that's the question part. So they describe to you everything in words, but then at the end, they tell you what they want you to know. And what they want you to know is going to make the let statement. Okay, so I'm going to write here the let statement. And what they want to know is how wide this thing is. So the let statement is going to be let x represent the width of the flower bed. Okay, and again, how I knew that is because they're asking for how wide. So that's going to be our variable that we don't know. Okay, now they did say that it's uniform width, right? Uniform width, which means everywhere I go around this rectangle, the width is x. So this is x, and this is x, this is x, this is also x. Okay, they're all x. That's the same, it's the same width. Now let me write my equation. So I'm going to switch to my green. Okay, so my equation goes like this. The question says that the combined area of the lawn and the flower bed is 165 meters. So the area of the lawn plus area of the flower bed is equal to 165 meters squared. Okay, so let's look at my picture. What's the area of the lawn? Well, the area of the lawn is 8 times 4. You can see that because they gave it to us. Now, what's the area of the flower bed? Okay, can't really tell, right? You can't really tell because we don't have a formula for this kind of shape that's like a border only, right? But the area of the lawn plus the area of the flower bed is really the area of the whole big thing, right? So this is just it's the area. And so instead of breaking it down into the parts, I'm going to put it all together. I'm going to say the total area is 165. And the total area is going to be for the large rectangle that we see. So what are the dimensions of this large rectangle? So here's the width and here's the length. Well, if the length was 8 before and I'm adding 8x to both sides, then this is my new length. And my width used to be 4, but I'm adding x to both sides, so here's my new width. So the total area is going to be 8 plus 2x times 4 plus 2x, and that's going to give me 165. Okay, so we're setting up the equation. And so now I'm going to solve this. I'm going to distribute 32 plus 16x plus 8x plus 4x squared equals 165. Let's rearrange everything into ax squared plus bx plus c equals 0. And I get 4x squared plus 24x plus 32 minus 165 equals 0. 4x squared plus 24x minus 123, I believe. Let's just double check. 133. Okay, 133 equals 0. Now, you have choices. You can factor all of this, right? You're welcome to factor. You might have a hard time with 133 if that's not a number that you know well. So try to factor it. If you're successful, wonderful. If you're having difficulty with it, then go to the quadratic formula. Okay, and quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And so x equals negative 24 plus or minus the square root of 24 minus 4 times negative 133 over 2 times 4. Okay, now I'm going to grab a calculator. So take a calculator, see what you get. I'm going to do it at the same time. I have, oops, sorry, I forgot b squared is 24 squared. So 576, and I'm going to have a plus. And I will have 2128 all over 8. Okay, so again, if you're able to factor this easily, please go ahead and factor. We use quadratic formula when we either cannot factor or it's just too difficult. Okay, but please, if it's an easy thing to factor, please solve by factoring. And this is 2704 over 8. And now let's just check with the calculator. Is 2704 a perfect square? So I'm just going to take the square root of it. Oh, and I get 52. So this is negative 24 plus or minus 52 over 8. And now I know that the plus or minus means I have two answers. My first answer is x equals negative 24 plus 52 over 8, or x equals negative 24 minus 52 over 8. The first answer is going to be negative 24 plus 52 is 28. 28 over 8, which, because it's a word problem, we're allowed to use decimals. 3.5. The second one is going to be negative 76 over 8, which is, use decimals again, negative 9.5. And I almost didn't even have to calculate how much that is because it's a negative number. So because x is the width of this border, x cannot be negative. Okay, so what happens is my equation gave me two answers like it always does, but I'm going to reject this one. And I'm going to say reject and give a reason because width cannot be negative. Okay, and so then I'm going to end with my concluding statement, which is going to be, therefore, the width of the border is 3.5 meters. Okay, and make sure you have the correct units in your answer. So let's just do a quick recap of what happened here. I got two answers, but one of them doesn't make sense for this question. If it was just a quadratic equation, like this one here, 4x squared plus 24x minus 133 equals 0, and I was just solving a quadratic equation, I wouldn't reject my answer. The only reason I'm rejecting it is because in the context of a rectangle and a border, my answer doesn't make sense. So here's an example where I got two answers like I'm expecting, but one of them doesn't make sense for the question. So I reject, and when we do that, we have to give a reason why we're rejecting. Okay, so reject it because the width cannot be negative. Okay, and then back to my first example with the choose two numbers, I got two answers. One of them was negative, but I didn't reject it because they're just numbers, and numbers are allowed to be negative. So the first case, I had two answers, and in my concluding statement, I had two answers. In the second case, I had two answers, but I had to throw one out, and my concluding statement has only one answer. Okay, so I hope you found that helpful. Please practice the problems, and thanks for watching.